Hi there, welcome to lecture two. What are we doing in lecture two? What the heck is LOGO? So back in the 1950s, Russia launched the first satellite that went around the Earth. And Americans were in deep shock that they were so far behind technology that Russia beat them to this goal. So there was this massive push to catch up. So lots of engineering, lots of science, lots of math, and it even filtered down to the public school system. Says we need more math people, we need more engineers, we need more scientists. So they started pushing heavy curriculums toward elementary school kids to get them interested in math, science, technology. Out of all of that, it was a way to teach elementary school children how to write code in a very fun way. And what they did was they took this huge sheet of paper and they put it down on the classroom floor. And then they picked up this robot and put it in the middle of the piece of paper. This robot had a place for a magic marker. Everywhere the robot went, it dragged this magic marker. So the magic marker marked the path that this robot was going. So anything the robot did, the magic marker would trace the path on that piece of paper. So I don't know if they had terminals or what they had, but there was some way for children to type commands to the robot. And that was the start of the Logo programming language. So fast forward to today. Well, we're not going to lay a big sheet of paper on the classroom floor, obviously. We're going to pretend like there's a sheet of paper on our computer screen, and we're not going to put a robot on our computer screen. We're going to put a virtual robot on our computer screen, and we're going to have a place where we can type commands to control the robot. The robot is called a turtle. It's pretty easy. Get a stack of index cards. Go to lecture one. You see anything interesting about UML-like diagrams, grab an index card, write a question on front of the card, on the back of the card, write the answer. Then, keep going in lecture one till you find another interesting thing about UML-like diagrams, grab another index card, write a question on the front, write the answer on the back, and keep going till you reach the end of lecture two. Then repeat the whole process for lecture two and keep doing that until you make it all the way. Let's see, there would be lecture 8. So once we cross, I think it's 8. Yeah, it's 8. Once we start 9, then we start using all of this knowledge that you gained on how to use UML-like diagrams with real with real classes and objects. So that's where we're heading. So the first 8 weeks, we're just learning how to use UML-like diagrams. And then the last half of the class, we're actually going to use our knowledge and actually do stuff in Java with UML-like diagrams, like build a card game. That happens in lecture 14. We're going to create a card game. You're going to create the card game. I'm going to get you started on it. Okay, where can you get help? Read the lecture notes. That is your best friend. That is the best place to get help. Go to the Magic Lab during normal business hours. They are closed 1 hour for lunch. You can come to office hours, which is depending on what class it is. Oh, this you're watching a video. Who knows? So if it's an in class, then it's like a half hour before the class starts. If it's a Zoom session, it's like a half hour before the Zoom session starts. If it's 100% online, then I've got hours posted somewhere on Canvas and when I have office hours. We don't have lab sessions anymore. You can send questions to the Canvas QA discussion and homework help board. That's there for students to ask questions and for other students to answer those questions. You can either join or start your own study group. The issue there is a lot of these people are gamers and their study groups, they don't stick to academic stuff. They drift off. The language is not appropriate for children. The topics they talk about, definitely not appropriate for children. If you are going to participate in one of those Discord groups, make sure there are no children that can hear anything about that conversation because it is definitely not age appropriate. I stay away from it. I don't like that kind of language. I don't like the topics they drift into, so I just stay away. You can also send me email. Okay, enough of all that. Let's look at logo. So what the heck does this a robot thing look like? Well, this is what it looks like today. You can go to the store and actually buy this, and this little turtle created this pattern. So you can see it's not just for children. It could be for serious graphic artists who want to create really interesting designs. And some people do use it for that. I use it for it. Whenever I need to create something that's really cool, I actually will write some logo code, like create a logo or whatever it is I want to do, and then include it in my PowerPoint slides. So I definitely use it for work. Here's one made out of Lego blocks. And then this is what it kind of looked like back when it started. It didn't look anything at all like a turtle. It kind of looks something like that. I don't know how close this is to what it really looked like. This looks a lot more modern because I can see chips. They didn't have chips back in the 50s. So I don't know if it started in the 50s or the 60s, but they definitely didn't have microprocessor chips. All right, moving on. So this isn't just for little children, so you can use it as a graphic artist. This was created with logo. If you're into math, then you can look at fractals. And if you're math and you know about fractals, you're going to go, ooh, and ah, that is so cool. If you don't know anything about a fractal, you're going, yeah, it's a tree that's leaning over. Yeah. So depends on whether you're into math or not, okay? Whether you found that interesting. We are not going to do any really sophisticated math in this course. We're going to do addition, subtraction, multiplication, and division, and that's where we are going to stop. We're not going to go past that. So don't worry about if you didn't. That looked like a tree to me. I didn't look at anything I cared about. Well, you're not into math, so that's okay. You don't need to be in the math to take this course, okay? All right, so what are we going to use? We're going to use this thing called Web Turtle. To find it, you go to Google. And sometimes it just will not come up, and you have to wait. Let's hope it comes up now. It does. There it is. Okay. If it doesn't come up, wait a half hour, try again. If that doesn't come up, wait another half. Usually comes up after an hour. I've never had to wait more than an hour for this thing to come up. Um, okay. Let's see this turtle or this robot. So you're gonna, that's the first command we're gonna learn is show turtle. And we always want to end all our programs with end, and we click draw it, and voila, there's our turtle, and it's pointing straight up. So let's follow the lecture notes. I don't want to drift too far away. So this is the drawing area. This is where our drawing is going to appear. This is where the turtle lives. Here's where you type computer programs, which is what we're going to do today. And these are for variables. Okay, so we just did show turtle and voila, a turtle appeared. First command we're going to do is move. Move is going to move this turtle in the direction it's pointing at. Let's move it 100 steps up. And I'm going to click draw it, and it moved from the center 100 steps up. Now, what do you think is going to happen if I click draw it again? Well, it doesn't move 100 steps from here. It goes all the way back to the middle of the screen, points straight up, and then moves 100 steps. So it's just going to repeat. So if I click draw it, it's going to appear like nothing happened. But something did happen. It did go to the middle of the screen, and it went up 100 steps. Okay, just be aware of that. So we can go about 140 steps in any direction. More than 140, we're going to start running out of real estate. So there, we went from the center 140 up. You can just barely see the tail of this turtle. What happens if we move down? If I go backwards from the center 140, you're going to see something that, you're going, what? All right, let's take a look. So you can see the whole turtle, and it moved from the center down 140. You can go, why? Well, you get what you pay for. What did we pay for this? Nothing. It's totally free. You get what you pay for. It's not perfect. It was never meant to be perfect. Remember, this was written for children. It doesn't have to be perfect. As some graphic artists do use it, and some people like me who know how to use logo and are very comfortable with logo, we can make stuff for PowerPoint slides and brochures and things like that that people ask us to create stuff with. So But again, it's primarily for children, so it doesn't have to be perfect. So what about going left and right? Well, in order to go left or right, we have to make a turn. So let me get rid of this and I'll show you how to make a turn. If I want to make a right turn, I go right. And now it's using a 360-degree circle. If we want to go 1/4 of a turn, 360 divided by 4 is 90. So we're going to do a 1/4 turn, and let's see what that does. So it went from pointing north to pointing east. Okay, that's 90 degrees. If I go 180 degrees, we're going to do a half circle. We're going to go up, and it's going to go all pointing down. And if I do 270, it's going to do 3/4 of a circle. So it went up and then it turned 90, then turned down, and now it's turning due west. Okay, that's 270 degrees. And what do you think is going to happen if I go 360? That's a full circle. It's just going to go circle all the way around and it's going to be pointing straight up again. So there it is. Okay, so this explains why you had to do those worksheets where, I had 0, 90, 270 on there. So get you used to degrees. Yes, there are some people in the class who've never worked with degrees, or they probably saw it in school and go, nah, not interested, went back to their cell phone and did whatever and just totally ignored it and never learned it. Well, now you're going to have to learn it. So lots of videos out there on how to learn it. Like, what videos? What are you talking about? Where are these videos? Okay, let's go find them. I am going to go to lecture 2, printed lecture notes and helpful resources. And looky here, a whole bunch of videos written for children to teach them about degrees and a circle. And there's somewhere in there is a Cartesian coordinate one, the XY coordinates. I'm not going to try to figure out which one, but it's in there somewhere. And then you can go find your own videos, of course. And you also got ChatGPT to help you. I don't know how much help it'll be for learning degrees. It might help. I don't know. You tell me. I don't use ChatGPT to learn about degrees and XY coordinates. I already know it. So let me know if there is a way you can use ChatGPT to make that easier. I'll include it in the notes. Okay, enough of that. Oh, we were going to turn and go 140. Let's do that. Okay, we're going to turn 90 degrees. So it's going to be facing due east. And we are going to move 140 and see what it does. Okay, about what we expected, right? We just see the little edge of the turtle. So what happens if we go left? I'm going to go left 90 degrees. So it's facing west. And we're going to go 140. You see, I wasn't expecting that. I was expecting to do the same thing as up and down, but it didn't. So that's an interesting thing. Again, it doesn't have to be perfect. This was written for children. Okay. So we know the limits, 140 in any direction. All right. So if I got the turtle pointing straight up and I type the command move 100, where is this turtle going to appear? I recommend you draw the box and you put the arrow where you think the turtle is going to appear on a sheet of paper. Pause the video if you need to. I'm going to show you the answer now. So it's going to start here and it's going to go up 100. So it's going to end up about right in there. So it's going to look something like that. Suppose I got that turtle pointing due east and I say move 100. Where is it going to appear? Pause the video, draw the box, draw the arrow. Where is it going to be? Well, it's going to be, well, pause the video. I'm going to tell you the answer now. It's going to be about right here. And there it is. Probably I got the turtle pointing up toward the corner and I go 100. Where do you think the turtle is going to be? Draw the box, put the arrow down there. I'm going to show you the answer now. It's going to be about right here. It's going to scope. It's going to go in the direction it's pointing at 100 steps. So it's going to end up somewhere around in there. Okay. Oh, we can go backwards. Yes, indeed. We definitely can. Let me go up 100. Let's move 100, go up 100. And now all I got to do is put a minus sign and it's going to start from the center and go down 100. Okay, so minus means go in the opposite direction. All right. Okay, this is an interesting one. A lot of people get this one wrong. Now, let's see how good you are with Cartesian coordinates. Suppose I'm over here and I say move 200. Where's this thing going to be? Pause the video, draw the box, draw where the turtle is going to be. I'm going to show you the answer now. Well, I'm going to talk about the answer right now. So it's going to go 200. Well, the first 100 is going to get us to the center of the screen. The next 100 is going to get us to right. So it's going to be about right there. So it's going to look something like that. Okay, now we're doing degrees. Now this is a 360-degree circle. 360 divided by 4 is 90. 90 degrees is a quarter of a turn. Quarter of a circle. Let's divide the circle into 4 parts, and they're called quarters, right? Hopefully you know that. If you don't, now's a good time to learn it. Quarter of a circle means 1/4 of a circle. This is 1/4 of a circle. Here's the second fourth of a circle. Here's the third fourth of a circle. Here's the last fourth of the circle. So what's unusual about Webb Turtle is 0 degrees isn't north. It is due east. Don't ask me why. That's when the guy wrote it. That's what he decided to do it that way, which is fine. He wrote it. He can decide what 0 degrees means. So if we go a quarter of a turn and a clock, the arms on a clock, they move like this. They go around like this. Counterclockwise means we're going to turn in the opposite direction. Okay. You're going, I don't understand what's the clock? What's arms on a clock? I get it, right? A lot of people they're all 100% digital and they never looked at an analog clock before. And you're going, what clock are you talking about? I've never seen this clock thing. That's a clock. Okay. And if you actually stare at a real clock, you'll see the second hand going around clockwise. Okay. And if you stare at for a real long time, you'll see the minutes turn clockwise. And if you stare at it for hours, you'll see the hour hand turn clockwise. Okay. All these hands on the clock turn clockwise. Counterclockwise means we go in the opposite direction. All right. So, okay. I don't know what all that's about, but we covered all of it. How to point the arrow 90 degrees. Well, 90 is right there. Draw the arrow, right? That was one of the worksheet exercises. Draw the arrow where it's supposed to be pointing at. Okay. Now, we know how to draw it to point to 90. And we know how to draw it. Oh, maybe we don't. Where is 135 degrees? Pause video if you need to think about it and draw the arrow pointing to it. I'm going to reveal the answer now. Well, 135 is greater than 90, but it's less than 180. In fact, 135 is dead center between 90 and 180. So it's going to point right here. Okay. And there it is. All right. Oh, what was all those lines? So I used Webb Turtle to draw these 10-degree tick marks. And so you could just count by tens until you get to 135. All right. Okay, suppose I got the arrow pointing straight up. I want to turn right 90 degrees. Pause video, draw the circle, draw the arrow. I'm going to tell you the answer now. So right means go clockwise. So we're going to start here and we're going to go this way, quarter of a turn, and we're going to end up pointing towards 0. Okay, there it is right there. Suppose I got it started like this and I want to go 90 degrees. Where is the arrow going to be? Pause video, draw the circle, draw where the arrow is. I'm going to tell you the answer now. Well, we're going to continue clockwise for another quarter of a circle. So we're going to go around 1/4 of a circle, and we're going to end up at 270. Okay, we're going to end up right there. Suppose I got the arrow pointing here, and I want to go right 45 degrees. Now, this is where half the class just messes this up royally. Where is it going to be? Pause the video and actually draw the arrow. I'm going to tell you the answer now. It is not your right. So if you think it's your right, you're going to say it's over here. Well, that's wrong. It is the arrow's right. So what do you mean your right and arrow? Go look at yourself in the mirror. Your right is your left and your left is your right. I'm serious. Go look at yourself in the mirror and raise your right hand or wave at you or whatever, and then look at the mirror. Your right is your left and your left is your right. That's what I'm talking about. We want to go with the arrows right. And the arrows right means we keep going in the clockwise direction. So 45 degrees is going to get us right between 180 and 270. Okay, it's going to get us right there. And that value is 225. All right. Suppose I'm at 225 and I want to figure out how many degrees do I got to turn to get to 180. What is the answer? Pause the video and think about it and write your answer down. Well, I'm going to tell you the answer. So it took us, we went to get from 270 to here, we went 45 degrees. To get from here back to 180, we got to go another 45 degrees. So we got to go clockwise 45 degrees. Well, okay, so that's the answer, but how do I do it mathematically? How do I do math? By math, I mean add, subtract, multiply, divide. How do I figure out from 225 degrees, how many degrees I got to turn to get to 180? Pause the video, write the math equation. It's simple. It's either going to be multiplication, division, subtraction, or addition. Okay, I'm going to tell you the answer. So we are at 225. If I subtract 180 from 225, I'm going to get 45 degrees. So we got to go 45 degrees. So it's a simple subtraction, okay? Again, all we're going to do in this class is math, addition, subtraction, multiplication, and division. That's it, just plain old ordinary arithmetic you learned in elementary school. Okay. Let's go the other direction. Suppose I'm pointing straight up. I want to go left 90 degrees. Where am I going to be? Pause video, draw the circle, draw the arrow. I'll tell you the answer now. So left means go counterclockwise. So we're going to go this way, 90 degrees. We're going to start here and go turn, 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 turn. 1/4 of a turn. There it is. We're going to be at 180. Oops. Yeah, right there. Suppose I'm at 180 and I want to turn left another 90 degrees. Where am I going to end up? Pause the video, draw the circle, draw where the arrow is going to be. Well, we're going to start here. We're going to continue going in the counterclockwise direction, 1/4 of a circle. Turn, 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 turn. We're going to end up right here. We're going to be at 270. There it is. Okay. Now, suppose I'm at 270. I go left 45 degrees. Where am I going to end up? Pause video, draw the circle. We're going to continue going counterclockwise. So we're going to start here, and this time we're only going to go 1/8 of a circle, half of a 1/4 of a circle. So we're going to go here and go turn, 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 stop right here. And we're going to end up right there. So let's see, let's look at that. There it is, and that is 315 degrees. Now, suppose I want to get to 0. What do I got to do? Addition, subtraction, multiplication, or division? I got to do something. Tell me how many degrees do I got to get from 315 to get back to 0? Pause the video, figure it out. Now, you're going to have to think about this one. This is a tricky question. Okay, I'm going to tell you the answer. It is not 315 minus 0. Because, you know, we already know the answer is 45, but how do I get the 45? Well, remember, going around a full circle is 360 degrees. 360 minus 315 will give us 45 degrees. Where is that math? There it is right there. Okay, so what do you mean? What is this 360 thing? So I don't know about your generation, but in my generation, whenever we made a mistake and we got to back up, we'll say, well, I did a 360. Means I had to turn around and go back. Well, I went around in a full circle. 180 is you turn around and go back. 360 means you went around in a full circle. I did a 360. Had to rethink the problem. Or if you want to back up, you say I did a 180. So we actually said stuff like that in my generation. Okay, what else do we want to talk about? Points. Yes, let's just point to things. So we know 0 is due east. I can point due east. So I say point 0. Point me due east. So if I want to point north, I got to start from here and go counterclockwise, 1/4 of a circle. So I'm going to go turn, 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 turn. I'm going to be right here. I'm going to be pointing north. So point 90. And if I start here and I go another 1/4 of a circle, I'm going to keep going counterclockwise, 1/4 of a circle, turn, 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 turn. I'm going to be right here. It's going to be 270. 270 is due west. 270. 270. Thank you. Oh, down. We were at 180. No, did I even show 180? I did not show 180. There's 180. From 180, we turn another quarter, we go 90. Okay, I messed all that up. How about we start over again? Okay, that's going to point due east. If I go 90, it's going to point north. We're going to turn a quarter of a circle. Start here and go turn, 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 turn. We wind up pointing north. If I start from here and I go another quarter of a circle, I'm going to go turn, 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 and that's going to be due west. And then if I go another 90 degrees from here and turn, 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 another 90 degrees, that's 270. I'm going to point due south. And then if I start from here and go another 90 degrees, turn, 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 I'm going to be back at 0. So I can say 360 or I can say 0. Take your pick. It means the exact same thing. Okay. Okay, so now we know what pointing does. All right. Everything I just said. So if I went too fast, you can follow the slides. This is everything. I don't know what's going on here. Probably more turning. Okay, let's look at this. The order of the commands make a big difference on what happens on the screen. I'm going to take these two commands. I'm going to do it in this order, and then I'm going to reverse the order and run it again. But right now, let's just run this. So where do you think this turtle is going to end up if I run these two commands? Pause the video, draw the box, and draw where the arrow is going to be. Okay, I'm going to tell you the answer now. Well, it's going to move up 100. Then it's going to turn to the right 90. So it's going to be up here pointing east. Okay. And there's a picture of that right here. And you're going, now I'm going to take those same two commands and I'm going to reverse the order. So remember, let me back up. This was move first and then turn right. Well, I'm going to reverse it. I'm going to right and then move. So this is right move. Now, where is this turtle going to end up? Pause the video, draw the box, draw where the turtle is. So it's going to turn right 90, which means it's going to point due east, and it's going to move 100. So it's going to be here. So remember, when it was reversed, it was up here. When we reverse these two commands, it's down here. So it's a totally different place. Okay. And if you don't believe me, you can actually run these commands yourself. All you got to do is copy and paste. So just copy, come over to WebTurtle, paste. So these are comments, draw it. So there's that. And then you can reverse the order. Same two commands in reverse order. And now it's up here. Okay. Big difference. Order matters. Order, just remember that. Order of the commands matter. Let's draw this dashed line. I'll start fresh so you know I'm not cheating. First thing I'm going to do is just show that turtle so I can figure out where the heck is this turtle. Then I'm going to end this program, always include an end. And I'm going to start off by just, okay, let's see where that turtle is. Should be center of the screen pointing straight up. And now what I'm going to do is draw 25. And there's the first part of our slash line. And now I want to have an empty 25 degrees. I'm up. So with the pen up, I'm going to move 25, but the pen is up. So it's not going to draw anything on the paper. And now I want to put the pen down and I want to draw another 25 with the pen down. And there it is. And now I want to pick the pen up off the paper and move another 25. And there it is. And then finally, I want to put the pen back down and move another 25 with the pen down. And lo and behold, there's our dashed line. Okay, that's how you make a dashed line. Hopefully that all made sense. I think next thing we're going to do is a square. Yes, indeed. Let's do a square. All right, I'm going to start fresh so you know I'm not cheating. First thing I want to do is just show that turtle, find out where the heck I am. And then I'm going to end the program. All right, to draw a square, I got to draw 4 sides. Let's draw the first side. So I'm just going to say draw 100. That's the left side of my square. Okay, now I want to turn the turtle to the right. So it's pointing due east, right turn, 90 degrees. Let's see what that looks like. Then I want to move that, draw the top of the square, draw 100. And there it is. Now I got to turn the turtle down So it's pointing down. So I'm going to take another right turn, 90 degrees. Now it's pointing down. Now I'm going to draw the right side of the square. So draw 100. Now I need to turn the turtle 90 degrees, so it's pointing due west. So right turn 90. And now I'm going to draw the bottom of my square. I do have a problem here. I've got 90 plus 90 plus 90, which is 270. I want to go all the way around, fully enclosed polygon, 360 degrees. I need another 90 degrees. So I go 90 plus 90 plus 90 plus 90, which is 360. So go ahead and finish this off. So we get 360 degrees. And we're back to where we started. The turtle's pointing straight up, and there is our square. Notice how I did this square. I wrote a command and then hit draw. Wrote another command, hit draw. Draw another command, hit draw. Now, I watched a lot of people who took this class. They tried to do it like this. I said, I'm smart enough. I can figure this out without keep drawing it. Let's see. I know I got to draw something 100, and I know I got to turn some kind of way in 90 degrees. Then I got to draw another 100, and then I need to make some kind of a turn somewhere and draw another 100, and make another turn somewhere and do that, and then I got to draw the next side, and something about making this 360. So I got 90, 90, 90. That's 270. So I guess I need to make another turn, so 90 degrees, and that should be a square. And it's not. I don't recommend doing this. I don't recommend you type all of these commands without even seeing what you're doing. This is way too difficult. I recommend you do it the way I do it. One command at a time and hit draw, and you can actually see what's going on. And then you can say, okay, do I need to turn? Do I need to make a line? What do I need to do from this point? That's how I recommend you do this. Okay. Um, you can, so this is all the commands to draw a square. You can pick any corner. Let's pick this corner. First thing I'm going to do is just draw 100. So it's going to draw the top, and then I'm going to do a right 90, which means we're going to point straight down. Then I'm going to draw 100, which draws this line. Then I'm going to do a right 90, so I'm pointing due west, and then I'm going to draw the bottom line. Then I got to turn 90, so I'm pointing straight up. And then I got to draw this line, and I've just completed my square. Okay. Pick any corner and type the commands in that order, and you will get a square. Let's do a triangle. No, is that the next step? I think triangle is next. Yes, it is. Let's do a triangle. I'm going to start over so you know I'm not cheating. Show, turtle, end the program. Always have an end to the program. Okay. Let's just draw one leg of this triangle. So I'm just going to say draw 100. Now here's the part where people get very confused. I know I need to make a turn, but how much of a turn? Hit the pause button and think about it. I'm going to tell you the answer now. So a triangle has three sides. I know I got to make a full polygon, I got to go 360. 360 divided by 3 is 120. So I'm going to turn 120 degrees here. And then I'm going to draw 100. And then I'm going to do another right 120, and then I'm going to draw 100, and then I'm going to do another right 120. And now I'm going to see what I got. Hopefully I got a triangle. Yeah, but do you know if any triangles can stand up on a tabletop like that? I don't. I've never seen that. Something is not right with this triangle. This base has to come down like 30 degrees. So it's resting on top of my table, and then it'll look like a triangle sitting on top of a table or on the floor or whatever. Triangles can't sit on the floor like this. It'll fall over, go boom. So how do I fix this? So I already told you got to turn 30 degrees. How do I know I got to turn 30 degrees? Well, because I took geometry in high school and we learned about the 30, 60, 90-degree triangle. If you took geometry in high school, you know it too. You got to turn 30 degrees. So I'm going to turn it in the wrong place just to show you that order of the commands matter. Why is that doing that? I have no idea. There, okay, we're back. I'm going to put it right here, right 30 degrees. This isn't going to do diddly squat anything, but that's the number of degrees I need to turn. Going to draw it, and absolutely nothing happened. Well, the turtle did turn. So why isn't the triangle resting on this edge on the floor? Well, because I drew this triangle, and then after I drew the triangle, I turned the turtle 30 degrees. The only thing that turned was the turtle, not the triangle. I did it in the wrong order. So instead of doing it after I draw the triangle, how about I turn 30 degrees before I do draw the triangle? So I'm going to say right 30, and now I'm going to hit draw it, and lo and behold, now the whole triangle is 30 degrees turned. Okay? Hopefully this makes sense. Order of the commands matter. You've got to get the order right, or this is not going to work. Here's another easier way to draw a triangle. Because who's going to, unless you took geometry and you remember 30, 60, 90-degree triangles, you're not going to remember to turn right 30 degrees. You might remember to turn right, but you're not going to remember how much. Got a solution for that. Let's try drawing this triangle. So we start off with the turtle pointing straight up. I don't want the turtle pointing straight up. I want the turtle pointing due west. Well, I know how to do that. Right 90. Now I'm going to, and then let's see what that looks like. There it is. Now I'm going to draw that bottom line, draw 100. Now I need to turn left 120, so it's pointing up. So left 120 and draw. And now I'm going to draw that line. Draw 100. And now I'm up here. I got to turn the turtle 120, so it's pointing down. Well, another left 120. And then draw the last leg of this triangle. And now I've got 120 plus 120, 240. I need to go a full 360, get a full polygon. So left 120. 120 plus 120 plus 120 is 360. I want a full circle. That's what I want. Come on. Can't type. 120. Here we go. Draw it. Okay, there it is. Ta-da! Life is good. We are happy. Hopefully this is impressing you. All right, everything I said, but in slow motion, so you can take it at your own pace, one slide at a time. Everything I talked about, it's all there. What's going on here? How do I make a diamond? I'm going to fudge because we wrote this command already, just to save 2 minutes instead of me retyping everything. This draws, got 2 ends. I only need 1 end. Thank you very much. This draws a square. I don't want a square. I want a diamond. Pause video and tell me how am I going to get a diamond. Think about it. Okay, I'm going to reveal the answer now. I got to turn 45 degrees, and I'm going to put it in the wrong place. This is not going to make a diamond. Turns the turtle, but it doesn't turn the whole box. I need to turn the whole box 90 degrees because I did it in the wrong place. All of this drew this box. And then after I drew the box, I turned the turtle 45 degrees. That's not helping. I want to turn the whole diagram 45 degrees. So I'm going to put this at the top. Order of the commands matter. And now I have a diamond. Hopefully that made sense. Oh, there's other things we can do. So if you want to see some of the other commands, you can go home and you can available commands. You can read about all these different turtle commands. We didn't cover all of them. We're not going to cover all of them. We just want a very simple introduction to this. And let's at least look at a couple of the commands. I'm going to show my turtle if I can type in the program. Draw it. Let's just draw a line. All we need for demo. Oops, draw, not line, draw. Okay, there's my line. I'm going to try coloring this line. I'm going to go color green. This is not going to do diddly squat anything. Why? I said green. Why isn't this a green line? Pause video, think about it, tell me why. Or you don't tell me. Write down why this is not a green line. I'm going to tell you the answer now. Because I drew the line and then I changed the crayon that's in the turtle from black to green. But I already drew the line. So if I want to draw a green line, I got to change the crayon from black to green before I draw the line. Order of the commands matter. And now I have a green line. I can also change the thickness of this line. Thick 10. This is going to draw a very thick line. Okay. And you say, well, that's too thick. Well, cut it in half. Draw 5. Oh, that's still too thick. Well, make it 2. So perfect. That's what I want. Okay. So you can change the thickness of this line. All right. Here are some of the colors: black, white, red, orange, yellow, green, cyan, blue, purple. Don't go crazy with the colors. Um, I don't know, seagrass. This thing doesn't know what seagrass color is. And it says, well, I don't know what that color is, so I'm going to go to black and give you black. Okay. It doesn't know that. It only recognizes very, well, it does recognize these. Okay. What the heck is cyan? Well, you can find out real easy. Cyan. That's cyan. Okay. I didn't know that until I actually started teaching web turtles. Oh, that's cyan. I didn't know that. Um, okay, because that was not in my box of 7 colors when I was a kid. Remember, I don't know. I don't know what your generation did, but our generation, we didn't have video games, and there wasn't cartoons on the TV 24/7. So we had to spend a lot of our time figuring out how to entertain ourselves. And one of the things that we did as kids was color in coloring books with crayons. And you always start off with the box of 7 colors or 8 colors, depending on what manufacturer you got the box from. But very limited choices. And then if you're lucky, your parents brought you the 64 crayon box with all these different colors. Yeah, fun times. Um, okay, I already told you why this is wrong. We drew the square and then we changed the color and the thickness. If you want to see the square in red with a thickness of 10, you've got to set that before you draw the square. Okay. All right. So we know about all that. What's interesting about this, I do actually want you to pause the video and look at this very carefully. There is something very unusual or interesting about this, and I highlighted with different colors what I want you to pay attention to. So actually do pause the video and stare at that for a while. Okay, I'm going to tell you what I see in it. I see in yellow, draw 100, write 90. I see in cyan, draw 100, write 90. I see in green, draw 100, write 90. I see in purple, draw 100, write 90. It's the same thing. Draw 100, write 90. Draw 100, write 90. Draw 100, write 90. Draw 100, write 90. We're repeating the same 2 commands 4 times. Computer scientists don't do that. That's too much work. We're not going to repeat the same thing over and over and over again. Instead, we are going to make a loop. Says, what do you mean by a loop? I got a picture of it. Find the loop. Here's the picture of my loop. Gonna start over here and I'm going to draw 100, write 90, and then I'm going to go around the loop, and then I'm going to draw 100, write 90, go around the loop, draw 100, write 90, go around the loop, draw 100, write 90. After I've gone around 4 times, it'll exit the loop. So it'll only stay in the loop 4 times as I told it to. You're only going to loop 4 times. So it'll do this command, these 2 commands 4 times. Well, how do we do that in Web Turtle? Pretty easy. Let me start over so you know I'm not cheating. I'm going to show that turtle. And then I'm going to end this program. Always do those 2 commands first. To go around in a loop, I'm going to say repeat. I'm going to repeat 4 times to draw a square, and the end of a loop is next. So this is the end of the loop. This is the beginning of the loop. Beginning of the loop tells you how many times you're going to go around. And I'm going to draw 100, write 90. If I can type, write 90. And let's see it. And we have a square. Notice the indentation. Inside the loop, I've indented. You don't have to indent, but it makes the code easier to read. What do you mean? Well, what happens if I don't indent? Now, you're going to see repeat 4 and says, okay, it's repeating something, but what? Well, now I'm going to have to read code to figure it out. Well, it's repeating that. It's repeating that. Oh, there's the end of it. I figured it out. So this isn't bad. There's only 4 lines there. What if there was 1,000 lines between this repeat 4 and this next? Now you'd have to go through 1,000 lines of code before you figure out where the end is. The solution to that is just indent. And then you don't have to read. You can just look at it and say, oh, this is obvious. These 2 lines are being repeated 4 times. Pretty simple. That's why I want you to indent. Now, if you don't indent, some of your homework questions might be marked as wrong. I want you to indent. Okay? If you're inside of a loop, indent. Okay. Next. So we did the square. There's the square. So this is hard to read. look, notice how hard to read this is. Well, I know I'm going to do something 4 times, but what? I'm going to draw, and then I'm going to turn, and then, oh, that's it. I'm going to just draw and turn. But you have to read the code to figure that out. Whereas if you indent, it's obvious. You're going to do these 2 commands 4 times. You don't have to read every single command to find next. Hopefully this is making sense to you. And you're going, I don't get this indent. Why is this indent so important? Well, go take Python and you'll figure out why indent is important. You can't write any Python code without properly indenting. The code won't run. Python is well known for, you must indent properly. And if you don't, the code will not run. The old original Fortran, you had to indent the correct number of lines, or it would not run. I remember those days. The new Fortran doesn't do that. But the old one did. It strictly enforced indentation. Okay. Okay, we did this. What are we doing now? I don't know. It looks like we're just explaining what's going on. Oh, let's do this one. We're going to make a square that's way too big. That's not going to fit. I'm going to change this to 200. The square is way too big. It's going to be twice the size of this square, and it's not going to fit. There it is. How do I make this 200 width by height square fit inside of my window? Pause video. Think about it. You're going to have to spend a couple of minutes thinking about it. I do actually want you to pause the video and really think about this. What do I need to do? I'm going to tell you the answer now. Well, the first thing I got to do is move this turtle down before I start drawing so that we at least get this side showing. So let's do that. So before I start drawing the square, I'm going to say move minus 100. 100. Let's see what happens. Okay, now at least I see this edge. Now, what about these 2 edges? What do I got to do? Pause video, write down what I got to do. What I have to do is get the turtle over here and then draw the square. So I got to move the turtle over here and then draw the square. Well, how am I going to do that? Well, the first thing I got to do is just turn the turtle. So left turn, 90 degrees. Then I want to move 100. Now, if I draw that, it's not going to work. Like, wait a minute. What do you mean it's not going to work? You said you wanted the turtle over there. Hello. Doesn't work. So why? What happened? Well, look where the turtle is pointing. It should be pointing straight up. So there's the problem. We want the turtle pointing straight up before we start the square. So let's turn the turtle right 90 degrees. So it is pointing straight up, and oh, come on, I'm clicking on it. Got it in the wrong place. There it is. Ta-da! I turn the turtle left, move 100, and then point the turtle straight up. And there is my big, huge square. Okay, so hopefully that made sense. If I went too fast, you can go through the slides. It goes through it one step at a time. I'm going to get to the end. And there's the end. Okay, so if I went too fast, you can go back through the slides. Polygon has 4 sides. What happens if I make an octagon? What would happen? How do we make an octagon? Stop that. Why are you doing that? Don't do that. I just want to make an octagon. An octagon has 8 sides. So we're going to go about 50. And now you got to figure out, well, how do I turn? So for 4 sides, I turn 90 degrees. I'm doubling the number of sides, so I got to decrease by half to turn. So I'm going to go from 90 to 45. And going, what? What you want a total? You want a multiplication product of 360. 8 times 45 is 360. That's why it's 45 degrees. You know, what? Take 360 divided by 4, and that'll give you 45, okay? Not by 8. Take 360 divided by 8, and it'll give you 45. Hopefully one of those things clicked. It's 45. All right, let's draw the octagon. There it is, my octagon. What if I want to go to 16? Well, we're doubling that. We got to half this. and we got to half this. Now there's a problem. Half of this is 22.5. This thing does not do fractions. You cannot do 22.5. It won't work. So we need to go 22 or 23. That's as close as we're going to get. Let's see what that looks like. Here we go. Do you see it's kind of looking like a circle? What if I go 30 times around? No. Do I want to go 30 times around? Let me think. I want to go 36 times around. Let's go 30. Make the math easy. I'm going to go 5. And 36 times what's going to give me 360? 10. Or 360 divided by 36 is 10. Well, however you want to do the math, that's how you determine what this number is. 360 divided by 36 is 10. Or you can say 36 times 10 is 360. So whatever it takes to get this number, that's all you need. Let's see what that looks like. That looks like a really good circle. Here's the most perfect circle this thing can draw. I'm going to go around 360 times. Every time I turn, I'm going to draw. I'm going to take one step and I'm going to turn 1 degree. So 360 times 1 is 360. Here we go. This is the most perfect circle that WebTurtle can draw. It cannot get any better than this. Now, the $1 million question is, how do I make the circle bigger? Pause the video, write down your answer. Well, I can increase the how much I draw. So I've been drawing one step. Let's draw 2 steps. Now it's going to be twice as big. I'm going to put it back at 1. How do I make the circle smaller? Well, you can't. Not by draw. It doesn't do fractions. That's not going to work. It doesn't know about fractions unless they fixed it. Seriously doubt it. Let's find out. I'm going to be shocked if this works. Yeah, it doesn't work. Doesn't know what fractions are. Okay, so set it back to 1. So what else can we change? Pause the video. Think about it. The only thing we can change now is this number. So let's change that to a 2. So a tighter turn. So the circle is much smaller. Make the circle even tighter. Go by 4. Circle's even going to be smaller because we got a tighter turn. You can go to 8. Circle's even going to get smaller. Tighter turn. And you're going, so what's the point of all this? Well, you can draw some artsy stuff that kind of looks like that. I did that just by decreasing the size of the circle. I'm telling you, you can do some fancy graphic arts with this stuff, okay? It's not just for little children to play around with. You can do some serious artwork with this. Okay, so we talked about bigger, smaller, all that stuff. Let's talk about methods. So we're finally going to do a method. I'm going to start over. Show turtle. End the program. And now, instead of writing code here, I'm going to say, call the method name square. I don't know if we start at square in the lecture. What do we do in the lecture? No, we start with circle. Okay, we'll do circle. Sure, why not? Sure, go for it. Circle. We're going to call the method circle now. So this is really easy to read. We're going to show the turtle and draw a circle. Okay, well, in order for this to work, we actually have to write the code for circle. We're going to go below the end, below the end of the program, below the end of the program. We're going to define a method called circle. I do that by saying #, name of the method is circle. The end of the circle is return. This is the beginning of the method. This is the end of the method. Now inside of here, I'm going to indent because I'm inside the method circle. We have to write the code to actually draw the circle. Well, that is a repeat block that repeats 360 times. And we end the repeat block with next. Inside this repeat block, I'm going to indent once because we're in the method. Then I'm going to indent again because we're inside a loop. So I'm going to be here and I'm going to say draw 1. And then I'm going to indent once because we're inside the circle. Stop that. Why does it keep doing that? Oh, now it's all messed up. Okay. Indent once because we're inside the circle. Indent again because we're in the repeat block. And I'm going to go right 1. Double indent. I do a single indent here because I'm inside the circle. I do a single indent here because I'm inside the circle. This is a double indent. The first indent is because I'm inside the circle. The next indent is because I'm inside this repeat block. Hopefully you understand this. When we get to inside of the repeat block, we've got to do another indentation. We do 2 indentations because we're inside a repeat block and we are inside of a method. So a double indentation. If you don't do these double indentions for homework, it's going to be marked wrong. The indentation is important. Okay, let's take a look at this. Let's see if this works. There it is. So what did just happen? We know we drew a circle because it says go circle, and it's just going to execute all this code. We don't really particularly care how it draws the circle. All we know is that if we want to draw a circle, we just say go circle and it draws a circle. That is the magic of methods. We just call the method, and we did all the hard work of putting all the code in there to make the method do something interesting. And now whenever we want to call the method, we just say go circle. Hopefully this is making sense. I got some slides. So this is all the code we wrote. Again, here, all we're doing is calling the method go circle. And we know that inside that method is all the code to draw a circle, which is why this works. Let's do a square. I'm going to start over so you know I'm not cheating. First thing I want to do is call show turtle. Going to end the program. I want to draw a square, so I'm going to say go square. Going to call the method called square. Now I have to write that method. Drop below the end. Below the end, pound sign. Name of this method is square. Help if you could spell. The end of the method is return. Make sure you have that in there. I'm going to indent once because we're inside the method. I know how to draw a square. It's a repeat 4 times because I've got 4 sides. So repeat 4 times. I know how to end a repeat block. It's by next. Inside of this, I'm going to double indent because I'm inside the method square and I'm inside a repeat block, and I'm going to draw 100. And then a double indent again. Once because we're in the square, another time because we're in the repeat block, and I'm going to turn right 90. Now this is going to draw a square. And there it is. Let's do triangle. Start over so you know I'm not cheating. We want to first show turtle. Then we want to do an end. Inside here, we want to say go triangle. And now I need to create the method triangle. I'll start with that pound sign. Then the name of the method, triangle. Notice the name of this method matches the method that we're calling. It has to match. Okay. And we are going to call return. Now I'm going to do a double indent. The first indent is because I'm in the triangle method. The next indent because I'm inside a repeat block, and I'm going to go draw 100. Then I'm going to repeat that. Double indent because I'm in the triangle method. Another indent because I'm in the repeat block, and I'm going to turn right 120. This should draw a triangle. And there it is. You go, wait a minute. We got to turn it 30 degrees. Well, I can turn it here if I want to. Right, 30. That's one way to do it. Or I can turn it in here if I want to. Right, 30. Either way works. Okay, we get a square, we get a triangle. Okay, I think the next thing is 36 squares. Yep, 36 squares. Let's do 36 squares. I'm going to start over so you know I'm not cheating. First thing I'm going to do is just call show turtle. End the program. I want to draw 36 squares. I'm going to put a repeat block in here 36 times. Going to end this repeat block with next. Inside this repeat block, I'm going to say go triangle. No, go square. We're doing squares. Go square. Now I'm going to drop below the end and create the square method. Pound square. It is important that the name of this method, square, matches what you're going to, what you're calling. Go. We're calling the square method. Make sure you spell square exactly the same way as you spell it up here. It has to match perfectly. The end of a method is return. Inside of here, I'm going to indent once because I'm inside a method, and then I'm going to repeat. I know I got 4 sides in a square, repeat 4 times, and the end of repeat block is next. Inside of my repeat block, I'm going to indent once because I'm in the square, indent another time because I'm in the repeat block, and draw 100. Then I'm going to end square, indent again because I'm in the repeat block, right 90. Okay, it's not going to do any good. This isn't going to do anything. It's going to draw 1 square. Why? There's only 1 square. Why? It says we said we did it 36 times. I don't see 36 squares. Why do I only have 1 square? Pause the video. Tell me why. I'm going to tell you why right now. Because, yes, we did draw 36 squares. They're all on top of each other. So instead of doing that, how about every time we draw a square, we turn right 10 degrees. Well, why 10 degrees? Because 36 times 10 is 360. Now let's run it. We're going to see 36 squares. And there's 36 squares. I think that looks pretty cool. I've got a graphic that shows the square. Here it is. This is the first square. Notice it is a square. And then after it draws that square, it turns 10 degrees and it's going to draw this square. Okay, there's the second square. And you can see the third square and the fourth square. And you can do all 36 squares if you want to go all the way around. But this is the first square. So there is a square there. This graphic would be a lot more impressive if we didn't have the spokes in the middle of the wheel. So how do I get rid of the spokes? Pause the video, tell me how. I'm going to tell you how. We're going to do it by not drawing the spoke. We're not going to draw the first leg of the square. We're not going to draw the last leg of the square. We say, well, how am I going to do that? You tell me, pause the video and figure out what do I need to change to make that happen. I don't want to draw the first leg of the square. I don't want to draw the last leg of the square. So how do I do that? I'm going to tell you the answer now. First thing I'm going to do is get rid of this repeat because it's not going to do me any good. And then I'm just going to repeat this 4 times manually. And now I don't want to draw the first leg of the square, so I'm going to change that to a move. I don't want to draw the last leg of the square. I'm going to move that to a move. Now let's run this thing. That's not right. Did something wrong. All right, let's try that again. I want to draw. No, I want to move. Come on, type. Move 100, right 90. Then I want to draw 100, right 90. Then I want to draw 100, right 90. And then I want to move, draw 100. No, move. I want to make that invisible. Move 100, right 90. Okay, that should work. There it is. Ta-da! Life is good. We are happy. Doesn't that look precious? Doesn't that look awesome? Doesn't that look like you want to just print it and hang it on your wall? Well, I think it looks cool. Let's do 36 circles. Show turtle. Show turtle. End the program. I'm going to do 36 circles. I know how to do that. I'm going to say repeat 36 times. I'm going to end this repeat block with a next. Inside of this repeat, I'm going to, what are we doing? We're going to call circle. We're going to say go circle. We're going to draw 36 circles. And I know after I draw the circle, I want to move to the right 10 degrees. Okay. So now drop down below the end. Stop that. Drop down below the end and write the method circle, pound, circle, return ends the method. Inside here, I'm going to indent because I'm inside the circle. I know how to draw a circle. Repeat 360 times, 360 times. End the repeat block with the next. Inside the repeat block, indent one because I'm in the circle, indent another time because I'm in the repeat block, and I'm going to say draw one step, if I can type. And repeat once because I'm in the circle, repeat another time because I'm in the repeat block, right 1. This is going to draw 36 circles. And there it is. Now that's art. You go, wait a minute, what's that turtle doing there? It's messing up my whole drawing. Well, comment this out. That's a comment. Now draw it. There it is. Perfect. Go get a really nice printer, get some really, really good paper, print it out, buy a beautiful frame for it, put it inside the frame, take it to an art gallery, put some ridiculous price on there, like $1,000, hang it on the wall and see if anybody will buy it. Okay. Let's move on to UML-like diagrams. This is everything I just did with the circle. We're going to cover that at the end of the lecture. Here is our UML-like diagram that we saw last week. Okay, so it's divided into 3 sections. Top section, name of the class, car. What's a class? It's a factory, produces car objects. Middle section, all the attributes that a car has. Well, this car object only has one attribute, color. We can change the color. We can change it to green, red, blue, cyan, orange, whatever color we want. This car can only go backwards, and stop. That's it. That's all it can do. Now, I got this new method in here in yellow. And notice the name of the class is car. The name of the method is car. They match. This is the constructor. I know it's the constructor because it has the exact same name as the class. The name of the class is car with a capital C. Name of this method is car with a capital C. Most Java software developers name their classes with a capital letter. It's not required by the language. That is just what almost every Java programmer ever met does that. They name their classes, they capitalize the name of their class. So if the name of the class is capitalized, the name of the constructor is capitalized. Now I'm going to show you how I can use this constructor to create one car object. This is so easy. Let's launch Notepad. I don't know what the heck all that is. Start a new tab. Okay, here's how you make a new car object in Java. The first thing I got to do is start with the word new. In order to make any new object in Java, I start with the word new. Can I make this any bigger? Let's go to Notepad. I know how to make it bigger in Notepad. What the heck is all that? I don't know. Start a new tab. Okay, new. Then I'm going to copy and paste the constructor. There's the constructor. How do I know it's the constructor? Name of the class is car. This has the same name as the constructor. That is the it has the same name as the class. That is the constructor. Copy it. Car. All statements in Java and then a semicolon. I have just written the code to make a brand new car object. There it is. Easy, sweet, simple. Look at it for a minute. If you need to pause the video to stare at it for a while, go ahead. I'm going to take it off the screen now. Now you get a sheet of paper out and write the code to create a new car object. I actually really want you to do this. Pause the video, get a sheet of paper out and write it. Now I know a lot of you aren't going to do it. I am telling you, we're starting off easy. Next week, we're going to add to this. And then we're going to keep adding to it until we get to midterm. And this is going to get complicated by the time we get to the end. But if we do it in gradual baby steps like we're doing now, it's going to be so simple. But if all you're going to do is go, I'm not going to do it. Well, you know, whatever. Hopefully you'll figure it out when we get to the end. Okay, for the rest of you, hopefully you actually did pause the video and you wrote your code. First word we're going to write is new, because in Java, in order to create any new object, we start with the word new. Then we got to find the constructor. Well, how do I do that? Well, the name of the class is car. This has the same name. That is the constructor. I'm looking for a method with that's named car, and there it is. Copy it. Paste it. Come on. Paste. Where's the paste? There it is. All statements in Java and then a semicolon. I just made a new car object. Hopefully that makes sense. Let's go on to the next slide. Make a new dog object. Pause the video, get a sheet of paper out, write the code, make a new dog object. I'm going to tell you the answer now. In Java, in order to make any new anything, word new. That makes a new object. Now I have to find the constructor. How do I do that? Name of the class is dog. I am looking for a method with the same name, dog. Well, here it is right here. That is the constructor. Copy it. Come back over to your editor, paste it. All statements in Java and then a semicolon. I have just made a new dog object. There it is. We are happy. I'm going to erase it. I'm going to move on to the next one. You make a new person object. Pause the video, write the code. Make a new person object. I'm going to tell you the answer now. In Java, in order to make a new anything, I can start with the word new. That's going to make a new object. I don't want a new object. I want a new person object. Well, I've got to look at the constructor. There's the name, person. I am trying to find a method with the exact same name. There it is. That is the constructor. The name of the constructor matches the name of the class. This is the constructor, okay? Walk is not a constructor because it's not named person. Sit is not a constructor. It's not named person. Stand is not the constructor. It's not named person. The only constructor we have is this one, named person. Copy it. Come back over to the editor, paste, and then a semicolon. We have just created a new person object. This has got to be so easy. I'm hoping you all have gotten this. Let's erase it. Let's go on to the next one. I think it's balloon. No, it's pencil. All right, write the code for a new pencil object. Pause video, write that code, and tell you the answer now. This is pretty simple. First thing I got to do in Java, in order to make a new anything, I start with the word new, N-E-W. Right? Now I look at the name of the class. The name of the class is pencil. I am looking for a method with the exact same name. Well, here it is, pencil. Copy it out. Come over here to the editor, paste, and then a semicolon. Notice the capital P in pencil. Why is that capitalized? Because the name of the method is capitalized. The name of our constructor is capitalized. Well, why is the name of the constructor capitalized? Because the name of the class is classified. It all has to match, okay? Name of the class starts with a capital. The name of the constructor starts with a capital. Make sure you have a capital letter there, right? Going to erase that. Now we got balloon. Write the code to make a new balloon object. Pause video, write that code, and tell you the answer now. Hopefully you've got this now. You start with the word new. Then you look at the class and say, well, there's the class. I'm looking for a method that's named balloon. Well, there it is. Copy it. Come back over to here, paste, and then a semicolon. I have just created a new balloon object. It is that easy. I am telling you, there's nothing hard about coding. I don't know when it's so complicated. I can't do it. If you can't do this, you're in serious trouble. You got more problems than just, yeah, you might want to go see a doctor or something. You can do this, okay? My gosh, this is not hard. Write the word new, find the name of the class, look for a method with the same name, and copy and paste it and end in a semicolon. That's it. That's all you have to do to create a balloon object, okay? I think the next one is two numbers. Yes, it is. Pause the video and create a new two numbers object. Wait a minute, that's not a thing. That's not a noun. It's not a person, place, or thing. What the heck is this thing? It's math. It does some kind of mathematical manipulation. These kinds of classes are more common than objects. So you'll find lots of objects like if you're doing a video game. But if you're not making a video game, you're going to see more objects that just does some kind of math or some kind of computation, or maybe it talks to a database or whatever, but it's not an object that you would see in a video game. No, it's not a person or a dog or a cat. So this is a lot more realistic, which is why we keep going back to this over and over and over again. So you're going to see more classes that look like this than you will see of dog and person and cat. Create a new person, two numbers object for me. Pause video, write that code. I'm going to tell you the answer now. First word is always new. In order to make any kind of a new object, we start with the word new, followed by name of the class. Well, how do I, the name of the constructor? How do I find the constructor? Pretty easy. Go to the class. It's two numbers. Find a method with the same name. There it is. That is the constructor. Copy the constructor. Come back over here, paste all statements in Java, and then a semicolon. I just made a new two numbers object. You're going, so what? Oh, well, so in a couple of weeks, we're going to learn how we can take this new two numbers object and attach it to these properties and call some of these methods. I'm going to save that for a later time. Right now, all I want you to be able to do for this week is create a new object. That's it. That's all I want for this week. Create a new object. Baby steps, baby steps. Back in the old days, I did it all in one lecture. And at the end of the lecture, people looked at me like I was crazy. Like, no, I don't understand this at all. This doesn't make any sense. And that's when I said, okay, I got to spread this out over 8 weeks or we're not going to make it. And so that's why it's like this. If I spread it out, people got it. And I guarantee you, most of you are going to get this. Anybody who's serious about this course and actually do all these things I tell you to do, like when I say pause the video, actually write code, you will get all of it by midterm. You'll be able to create this new two numbers object, attach these properties to it, assign values to it. So you can assign 2 to the number 1, 8 to the number 2, and then call multiply 2 times 8 is 16 and get 16 out of it. You will be able to do all of that by midterm if you actually do what I tell you to do. Pause the video and write this code out on paper. The first time you write it, you're going to mess it up. You're not going, I don't get it. I can't remember. But, we did this like 6 times now. So hopefully the people who did it, they've got it. They've mastered it. The person who just sat there and going, I'm watching TikTok. Don't care. They don't have it yet. Don't know what to say about that. All I can do is try, right? All I can do is try. I'm going to teach the people that are interested so they get it. And you're going, well, why do we even have to do this? Because Java is an object-oriented programming language. Everything in Java is object. Well, I'm not doing Java. I'm doing Python. Guess what? Python is an object-oriented programming language. It has objects in it. It has classes in it. It has properties. It has methods. You cannot write sophisticated Python code without encountering these things because you're going to bring in libraries that is object-oriented. It's impossible to stay away from it if you're just writing Python code because Python is an object-oriented programming language. Yeah, well, I'm just going to be a web page person. I don't need to know this. That's not true either. Because the hottest thing in web right now for web development is React. React is object-oriented. It has objects in it. It has methods that you got to call in it. It's almost impossible nowadays to write any sophisticated code without seeing objects, properties, and methods. It's just literally impossible. You don't want to learn this, then and if your major is computer science, well, then you need to find something else to do besides coding, with other things that a computer science major can do besides coding. If you're interested in coding, even if you want to just do web development, you have to master this. You don't have a choice because this is going to be your life. This is how you write code. You look at classes, you look at properties, you look at methods. This is why we're doing this. This is the intro class. We're doing it very gradually, very easily. Hopefully you've mastered how to at least create the object. The word new followed by the constructor. How do I find the constructor? I go to the class. I find the method has the same name. There it is. Copy and paste that in, end in a semicolon. I've just now made a new 2 numbers object. Okay, baby steps, baby steps. And that brings us to the dean's list. So at the end of the semester, all the dean cares about is, do your students know how to do all of this? That's it. That's all they care about. If you can do all of this, they deem the course success. Mission accomplished. You learned what you were supposed to learn in this class. That's why we go over this over and over and over and over. We're going to go over it practically every week. And then by the midterm, if you're still with me, I know a lot of you have already turned this off. You're not even watching this anymore. So this is boring. I don't care. Well, you will care when you take the final exam. You're going to care a lot. Those grades go to the dean. I'm going to go over it. Develop solutions to programming problems. So on the final exam, I'm going to give you an easy program to write in Java, and you're going to write that code in Java just to prove that you can develop solutions to programming problems, that you can write code. That's what that's all about, using proper syntax. Well, what the heck is syntax? It's the grammar of the programming language. So if we're writing Java code, it's the grammar of the Java language. So we already know some grammar. What do you mean we already know some grammar? No, we don't. Yes, we do. I want to prove it to you. Stop that. I know to make a loop 36, I got to start with 36 and put the number at the end of it. If I reverse that, this is not going to work because bad grammar. I broke a grammar rule. It's supposed to be repeat followed by number, not the number by repeat. Other grammar rules. Well, if I want to repeat something, I have to actually use the word repeat. I can't say, like, I'll just make up something. Do again. Do again. Not going to work. Bad grammar. The only thing that's going to make a loop is the word repeat in this programming language. So we already know some grammar rules, okay? If you break the grammar rules, program's not going to run. It'll give you an error message. So that's syntax. What's an example of bad grammar in English? Store, milk, buy, go, I. All the words are there, but you messed up all the grammar rules, and it doesn't make any sense at all. It's just total nonsense. Um, so that's syntax. What's semantics? Semantics is the grammar is perfect, but what comes out is wrong. What do you mean what comes out is wrong? I'm going to show you that right now with WebTurtle. Suppose I want to create a web show turtle, and I want to draw a square, and I write this code. Say, okay, that's going to draw a square. No, it's not. It's not a square. I've got a semantic error. Something is wrong with this code because it did not draw a square. I intended it to be draw a square, but it didn't draw a square. That's a semantic error. You got the wrong answer. An example in English of a semantic error is red ate a mountain. This is perfect grammar. You go to take that to a college English professor and say, is this good grammar? And they'll say, yes, that is perfect grammar. But it doesn't make any sense. Red is a color. Red can't eat anything. Yes, I know there are some people called red. But when I wrote this slide a bazillion years ago, I did not know anybody was actually named red. Now I see people who are named red all over the place, but I didn't know that. I should have picked a different color, but I didn't. I got to change the slide. Okay, red is a color. Can't eat anything. And if it could eat something, it definitely couldn't eat anything as big as a mountain. Nothing on this earth can eat anything as big as a mountain. Okay, so this sentence just doesn't make any sense at all. Perfect grammar, but it doesn't make any sense. The programming cycle. So if you actually Google programming cycle, you're going to see a lot more than these 5 steps. I threw all the steps away that has nothing to do with writing software, because when are you ever going to use them? Probably never. Most of you, if you're a computer science major, your goal is probably to be a software developer or a web developer or AI developer or a machine learning developer. You're going to be writing code. At least that's what most computer science majors strive for. Not everybody. Some people want to be network techs. Some people want to be the help desk tech. Some people, yeah. So there's all kinds of different occupations in computer science. Not everybody who's a computer science major becomes a software developer. But I think the vast majority of computer science, if you look at the four-year universities, the vast majority of computer science majors, their aspiration is to become a software developer. Oh, well. And that's what I love to do, write software. Why am I on this path? Oh, the cycle. Oh, why did I eliminate some steps? Because I kept the steps that only a software developer would see, because most of you people who are computer science majors, if you're going to enter the profession with that computer science degree, you're probably going to be a software developer. So these are the things you have to do. The first thing you have to do is get the requirements for the programming test that's assigned to you. So if you're a freelancer, it's pretty easy. Find a customer, ask the customer, what do you want this code to do? And the freelancer can say, I want to do this and I want to do that. And if this happens, make it do that. And this other thing happens, make it do that. And the person will just keep going on and on and on. You're going to write all these requirements down. Then you're going to negotiate a price saying, okay, if I do all of this, you're going to pay me this amount of money. And it's a negotiation. They say, I can't afford that. Let's knock some of this stuff off. And so it's a back and forth until you come to an agreement. So the agreement is going to be, if I do all of these things that I got written on this piece of paper, you're going to pay me this amount of money. It's a contract. Both people sign it. Voila, done. That's great if you're a freelancer. What if you work for a company? You're going to be placed on a programming team. The days that a single lone software developer is locked in the office, surviving, 24/7 on pizza and soda, that doesn't happen anymore. People write code in teams because programs are huge. I was once on a project. The program had 1 million lines of code in it. It was written by several teams of people. I was on one of the teams. We were just one team out of many other teams. Programs now are written by teams of people. So how are you going to get your requirements? This is up to the software lead. Now, when I'm the software lead, I just toss all the requirements out there and let people pick. And I encourage the interns to pick the easy ones. My best coders, they know that if they don't pick the super hard ones, no one else is going to pick them, and it'll just, and the project will never get done. So they are very compelled to pick the really hard ones because they're the only ones who can do the really hard ones. And it's usually not an issue because software developers, we love tough challenges. That's what we live for. We live, to do something new, something different, learn something, focus on a problem that they never solved before, and find the solution. I mean, that's what I strive for. I've been on many, many projects where on day one, I didn't even know the programming language the project was on. That's how I learned Java. That's how I learned Python. That's how I learned SQL. That's how I learned just about all my programming languages. In college, I only learned COBOL and Fortran. That was it. Well, my early days. Then I went back and got a CS degree, so I learned more languages. I learned Pascal and C. All the other languages I know now, I had to learn by myself. I did that by joining projects. And on day one, the first thing you're doing is learning that language as fast as possible because they expect you to be productive on that day. There's no sitting around for months and months and months trying to learn something new. No, you got to be productive on day one. Now I give interns 2 days. So I'm serious. We throw them into a project that I don't care if they know the language or don't know the language. It says, okay, now write code that does this. They got to figure it out. Now it's crazy easy, right? You just ask ChatGPT for help and it helps you. But back in the old days, there was no ChatGPT. You had to figure this out all by yourself. So it's gotten really, really easy now to pick up a new language. So it's not a big deal anymore. Okay, we are way off topic. So let's go back to requirements. So if you're on a programming team, so I already told you how I do it. Other team leads don't do it like that. I've been on many projects where, every 2 to 3 weeks they call a meeting and they'll say, okay, we need to work on this. So they call them user stories. And a user story goes something like, if I was a user of this program, I would like to be able to do, and then whatever it is. And that's the requirement. And they would read that out and they say, who wants to do that? And whoever raises their hand first or says, I'll take it, they get it. And it'll just go all the way down the list. Now, if you don't say anything, you just stand there like an idiot and you don't say, I'll take that. And they make it all the way down to the bottom of the list and you didn't pick anything. So here's what's going to happen. Whatever's left over, whatever nobody picked because they didn't want it for whatever reason, you get it. So you're really encouraged to pick something. Um, yeah, you can't just sit around and wait and say, well, I don't know if I want to do that. Do I want to? Because by the time you think it through, somebody else already got it. So you got to be quick. What I like is when they publish the list ahead of time. So here are all the things we're going to do, and we're going to figure out who's going to do it at the next meeting. But not every project lead does that. So I've been on other projects where the project lead just specifically assigns individual tasking. It says, you're going to work on this. You over there, you're going to work on that. And they decide who does what. And the advantage to that is now for sure the most difficult ones are going to get assigned to your best coders, and the easiest ones are definitely going to get assigned to the interns, which is the way it should be. And you have full control over it. So, but anyway, you're in a project. You've got some tasking now. Either you volunteered for it or got assigned to you. Those are your requirements. Now what next step is convert those requirements into a design that's actually going to work. So for this course, this is easy. You're just going to write pseudocode. What the heck is pseudocode? I'm going to give you an example of pseudocode right now. Pseudocode is just the code written in English. So for this project, we could say draw a line 100 steps long. This is what the code's going to do written in plain ordinary English. Okay, that is pseudocode. And that's what we're going to do for our design. Now, what if you're a professional and you got to sign something that's going to take 100 pages of code to write? Well, you're not going to do it in pseudocode. What you're going to do is break up your requirements, figure out what kind of classes you need, create the UML-like diagrams for every class. You're going to have, you'll put the name of the class on the top, and in the middle, you're going to put all the attributes of the objects of that class, and on the bottom, you're going to list all of the methods that the class that object can do. And you're going to make several of these objects. And then after you figured out what objects and classes you want, then you're going to draw brand new diagrams to show objects interact with each other. Example would be a pitcher and a catcher in a baseball game. Pitcher throws the ball to, they have to cooperate. They have to communicate with each other. And so there has to be some form of communication or something happens between these two people, these two objects. So, and you're going to set all that up, you know, which objects can talk to what objects and what can they talk about? What can they do? And then you're going to make a whole brand new set of drawings to show how objects are going to interact to events. Like if you're doing the avatar object, it's got to respond to the joystick or the keyboard or whatever it is that's controlling your avatar. Has to respond. You know, if you move your joystick to the left, you want your avatar to move to the left. Okay, hopefully you get the idea. And so that's going to be their design. But our design for this class, pseudocode. Okay, we are not going to create UML-like diagrams. We are just going to write pseudocode. That is code written in plain, ordinary English that describes what the code's going to do. Once you have your design, you're going to convert your design into code. And what I like to do is I like to take my pseudocode, put it in my Java code as comments, and then under each line of pseudocode, I actually write the real Java code that implements that. You go, what are you talking about? I'm talking about doing something like this. I gotta find it. Oh, it's a web page. Duh. So maybe I don't put that up here. Maybe I put that right here. And there's the code to draw a line. And so maybe next to it, I need to make a circle, right? And I would say something like draw a circle. Oh, I don't know, whatever description you need to describe the size of the circle, and then you would actually write the code for the circle, repeat 360, and go next, and go draw one, and write one. So you would have to somehow describe, you can't just say draw a circle, how big is the circle? Draw a circle, how draw one and write one or something. I don't know. I'm not going to put a lot of thought into this because that's just eating up time. But you would write something in there when in your design so that you'll remember how big the circle has to be. And then I would paste that comment right here, and then down here I would write this code just as you saw me do it. And that's how I do it. So not everybody does that. Very few people do that. In fact, there's a lot of people who don't write comments at all in their code, which is a shame because why do you need comments? I think it's easier to write code if you see what it is you're supposed to do. It reminds you that I need to write code that does this and only this. And if I need to do something else, I'll write another comment. I won't do anything else but whatever is in that comment. Makes coding really easy. It's really focused. Another thing is, if you don't write comments in your code, that code is going to come back and bite you. What do you mean? So you might have finished the project, months go by, and then you'll get the dreaded email. Hey, we got a brand new customer. They wanted to make all these changes. We saw that you wrote the code for this piece of it. We need you to come back for a couple of weeks and make that change. You don't have a choice. You have to say yes. If you didn't write any comments, I guarantee you're not going to remember what you wrote, why you wrote it, how you wrote. You're not going to remember any of that. You're not even going to have the design unless you saved it somewhere. That's not my problem because I've got the comments embedded in the code. I know what I was thinking when I wrote that code, so it's real easy for me to do that. And I have been called to do stuff like that. So that's why you want to put your comments in your code. It does make your life a lot easier. So that's coding. You're going to write the Java code, convert your comments into code. Then you're going to test. And this is where a lot of people start missing points. Testing is not to find bugs. You want to get paid. Remember, you're the freelancer. You made an agreement with your customer saying, if I wrote code that does all this stuff, you're going to pay me this amount of money. It doesn't say anything about bugs. And so what you're going to do is you're going to say, you're going to meet with your customer and says, okay, you tell me to write code that does this requirement. You're going to run the code and show the customer it does that requirement. And then you say, okay, now you ask me to do this requirement. You're going to run the code, show it does that requirement. You're going to go down the list, every single requirement. You're going to run the code, show the customer it does every single requirement. Then you're going to say, okay, it does everything you wanted, pay me. What if you're in a workplace? So that depends on the team lead. Some team leads will make you go through the same thing. So show me your requirements. Now run the code and prove to me that you've met the first requirement. Show me you met the second requirement, then the third, and go all, and it goes every single requirement. You run the code to show that you actually did it. I've seen a lot of team leads do that. It's the easiest way to see that it actually does work. I don't do that. I ask my people, write a test that tests to see if the code fulfills the requirements. So you've got to figure out how to write a test that tests to see if you met the requirements. It's pretty easy to do after you've got some experience doing it. It's probably hard for a beginner, but I've been doing it for 40 years. I can knock these off, in a few minutes, not a problem. And so that's what I ask my people to do. Just write tests to prove to me that you've met all of the requirements. And all I have to do is run their tests. I've been on other projects where we write a test plan that we give to a human tester to test every single requirement. These are very lengthy test plans. And most of them are checkbox things. So it'll say, do you see a line on the screen? And there's a checkbox. So if you do, you check the box. If you don't check the box, the test fails. So I've been on situations like that. And large companies, they have entire departments full of software testers, and that is all they do all day long to become a software tester. And so that is something you can get with a CS degree. I've hired many, many, many computer science interns as software testers to help test our code. And some of those people, because years go by and I'll get an email or a phone call from some company that says, hey, did you have an intern named blah, blah, blah back in a couple of years ago who was doing testing for you? And I'll say, yes. And I said, well, he applied to our company as a software tester. Can you give us a recommendation? So I really get these kinds of phone calls and emails. So some of these people actually did become professional software testers. They loved it so much. Um, so that is another option. If you want to have a computer science degree, but you don't want to write code, you could be a software tester. There's other things you could be a network tech, you could be desktop tech, you could be a database manager, you could be the system admin. There's tons and tons of professionals in computer science that are not coders. Okay. Okay, so that's testing. Okay, let's say you proved to the customer, you met all the requirements, you got paid. What happens now? Well, you go into maintenance mode. So what happens in maintenance mode? Bug fixing usually. That is like the highest priority after that. You negotiate with the customer. Okay, so um, the customer is going to find lots of bugs in your code, and I'm going to come back to you and say, hey, we found all these bugs in the code. Can you fix them? And then you negotiate a price, right? How many of these bugs do you want fixed? How much money you got? How much time do you have to spend doing this? Yada, 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 yada. And an agreement's going to be reached. So bug fixing is definitely part of maintenance. Also, if you was the freelancer, you probably sold this software to somebody who owns a company and they distribute it to their employees. So if you wrote HR software, they split it, they gave it to their HR people. If it was accounting, they gave it to their accounting people, yada, 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 yada. And people hate change. They will have a long list of complaints. Says, well, I don't like the color. I don't like the font. But some of the complaints are legitimate. It says, well, I tried to do this and the software won't let me do it. And it says, and there, look, when I do this, it dies, and so there'll be some fatal errors in there that have to be fixed. And there's also preferences that says, I can't do my job unless this feature is added to this code. I mean, our old software did it. Why can't the new one do it? And so you get complaints like that. So you have to add new features in it. You have to fix those bugs. That's all part of maintenance. This is after the sale, so you can still make money off of this deal. Now, if you wrote software that hundreds of thousands of people are using it, what you can do is charge a monthly subscription fee to everybody and saying, hey, if you want free updates, free security upgrades, pay this monthly maintenance fee so we can keep our team of people working on this and making improvements and upgrades to it. And then every time a new release comes out, because you're a monthly subscriber, you get it for free. And a lot of companies do that. You have to pay a monthly maintenance fee. Okay, so moving on down. Pseudocode, I already told you, it is code written in plain ordinary English that describes what the entire program is going to do. And I showed you a comment. A comment just describes what the next few lines of code here. So this comment says draw a circle, and these are the lines of code that draws that circle. And with that, we are done. I'll see you next time. Bye.